Hi and welcome to this Edexcel Maths GCSE Paper 1 higher tier prediction. Enjoy! Hi, welcome to this prediction from On Maths. Now, with this prediction, what we've done is we've looked at all the previous exam paper questions, seen what comes up regularly, what's long overdue to come up, and we've created this predicted paper. Now, this predicted paper you can also do online if you click up here, and it's completely for free, and you can even sign up to save your scores. Now, the online version will change the numbers each time you do it, so you'll get a unique experience. You won't just remember answers, but the methods you'll see in this video, you'll use exactly the same. We've also got topic busters on the site, which are just focused on a specific topic, and we've got them for all the Maths GCSE topics. We've also got videos on this site for every single type of exam paper question. And also we've got the revisionator on our site, which is for short, quick revision. So if you've got 10, 15 minutes and you want just a completely random selection of questions, then please go and check that out on our site. Now, as we always say with these videos, please do not fully rely on this as your only revision strategy. Please do this alongside all your other revision for these reset papers. If you've enjoyed this video, please click like. And if you want to see more from us, especially Paper 2 and Paper 3 coming up very, very soon, please click subscribe. Enjoy.
When you're asked to describe the relationship between two things on a scatter graph, the sentence you need to write is, as this one increases, this one either increases or decreases. So, as time of day increases, test marks, and because they're going up, it's a positive correlation, test marks increase. So there's a difference between describing the type of correlation or writing the type of correlation and describing the relationship. When you're describing the relationship, it's just as the one at the bottom increases, the one up the side either increases or decreases. So it says, using the scatter graph, the examination centre then conclude that time of day leads to positive effect on test scores. Are they correct to make this conclusion? Basically, this is a question about the fact that just because two things correlate does not mean that one causes the other. So a sentence like, there may be other factors such as, I don't know, what else? Tiredness, fatigue, tiredness. So try and make sure you give an example as well to support your argument.
At first glance, this seems like a really easy question. It seems like the answer will just be 80. But we've got to understand the way that bearings are written out. It says work out the bearing of A from B. It means that we are at B and we're trying to find where A is in relation to B. So the actual question is asking you for this angle here. Now don't forget, bearings are the angle going clockwise from north. So not so easy. The first step of doing this, and there are different ways of doing this, is just draw a line. In fact, I'll use my straight line one. Just draw a line straight down at B. If I can get it right, there we go. Now, north lines are always going to be parallel, and we can use that to work out this angle here. This angle here will be the same as this angle here because they're Z angles or alternate angles. So that's also going to be 80. We know this one is a straight line, so we know this is going to be 180 degrees. So all we need to do to work out the bearing is do 180 plus 80. And when you add them together, you get 260. So the bearing is going to be 260. Now there are other ways of doing it. You could have worked out this angle, because this angle and the 80 degrees over here are co-interior, interior, or allied angles, whichever one you want to call them. So they will add up to 180. So we know that one's going to be 100. And then what we could have done is 360 take away 100, because it's the full circle is going to be 360, and we don't want that 100 one. You'd also get 260. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88, and then we have two shoots coming from it. Now I need to find out which two numbers times together to make 88. Now a little tip, if you've got an even number, always pick 2. So 2 times 44. Now whenever we get to a prime number, we always circle it, because that's finished. So 44. Get another 2 out of that, we'll divide another 2 out of that, so 2 and 22, 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you're going to write 2 to the power of 3 times 11. Now don't work that out, because that will give you 88. So 2 cubed times 11 is 88. Okay, for Venn diagrams it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18 or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and. And it means it needs to be in A and B. It can't just be in A, it can't just be in B, it needs to be in both. And there's two numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are two numbers that fit that bill. So that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1 over 4, or a quarter.
Okay, so here we've got a lot of parallel lines, we've got an isosceles triangle going on, and sometimes with these questions there's a lot going on, and you just need to kind of strip it back and think, right, what part of this question do I need? Now my answer to this question is definitely not going to be the only one. There are multiple ways of doing this question. I'm going to show you what I think is the easiest, but you might disagree, which is absolutely fine. So if we have a look at these lines here, then you can see that they are angles in parallel lines. We're looking at the two red ones going diagonally. We're ignoring the bottom parallel line because we're not using the top one for this. And these two angles here, the 62 degrees and this one, are corresponding because they make F angles, and the way I remember it is corresponding. The reason why I've highlighted what it's called is, although on the website and on Maths you're not asked to write down the reason for it, in the exam you will have to write down the reason for why this is 62 degrees, and the reason is because they're corresponding, and I remember it as corresponding. I remember the Z angles as alternate. I just bung a Z in there. That's just the way I remember it. And the other one is interior, co-interior, allied, whatever you want to call it. Okay, so you need to write down the fact that CDE, so angle CDE equals 62 degrees because corresponding. Okay. Right, now angle DCE, this one here, will also be 62 degrees. So angle DCE will also be 62 degrees. Okay, and this time it's because it's the bottom two angles in an isosceles triangle are always equal. Now by bottom I always imagine isosceles being like this. Okay, so it's always the bottom two. Clearly that isosceles is not like that, but in my head an isosceles is always this way up with the two equal lengths left and right. So it's the bottom two are always equal. So that's going to be 62 as well. So to work out angle angle DEC, that's what it says in the question. So angle DEC is going to be 180 take away 62 times 2. And the reason for that is angles in triangle add up to 180 degrees. And never feel like you're writing too much for the reasons. There are some key words in the mark schemes that are in bold that the marker's going to be looking for. So corresponding being one of them and isosceles being the other. And angles in triangle. Don't draw a triangle, just write the word triangle. I'm trying to save time, although having discussed it, I've probably not saved much time. Okay, so that's going to be 62 times 2. Well, 60 times 2 is 120, so it'll be 124. And then when you take that away from 124, you're going to get 56. Okay, so the angle's going to be 56 degrees.
Okay, first thing to realise with this question is how you calculate the mean. The mean is the sum of all the values over the amount of the values. Now this actually creates a triangle, just like speed, distance, time triangle. Works in the same way. So we have mean here, we have the sum at the top and the amount at the bottom. So we normally do the sum divided by the amount, but actually with this question we need to go the other way. And we need to work out the sum or the amount or whatever. Let's have a look. So it says there's 12 boys and 8 girls. So in total there's 20 children. So that's the first thing we need to realise. It says the mean number of coins for the children is 15. And the mean number of coins for the boys is 13. And we've got to work out the mean number of coins for the girls. So we know how many girls there are, which is 8, but we don't know the total amount of coins for the girls. For the boys. Okay, so where do we start? Well, it would be helpful to work out how much coins there are in total. So if I look at the triangle there, we know, so let's write down total children. I'm going to try and show my working out as I go. We know that the mean of all the children is 15. So in my triangle, I've got 15 for the mean. We know that there are 20 children in total. And we can work out the sum by timesing those together. So we're going to do 15 times 20. So there's 300 coins altogether. Okay, so now next we're going to work out, we're given the boys, so let's work out how many the boys have. So same triangle, we know the mean for the boys is 13, and we know that there are 12 boys. So we'll do 13 times 12, which is 156. So to work out how many girls there are, or to work out the sum of the girls, we're going to do the sum of all the children, which is 300, take away the sum of the boys, which is 156. So we'll do 300 take away 156, which is 144. So we know what the girls add up to, because if the boys add up to 156 and the total children adds up to 300, then the girls must add up to 144. But we're asked for the mean for the girls. So to work out the mean, we just go back to our standard formula we had at the start, which is this one. To work out the mean, it's the sum, which we worked out as 144, over the total, and it says there's 8 girls. So we do 144 divided by 8, which equals 18. So our answer is 18. Okay, this is quite a lengthy question, and again, it's one of those questions, there's multiple ways of doing it, so if you've got a technique that works really well, stick with it. But with this question, and with any fraction questions, you need to make them top-heavy first. So that's what I'm going to do with both of these fractions. So 6 1/3. And to make it top-heavy, you times by the bottom, and then that answer you add to the top, and then you keep the bottom the same. So 6 times 3 is 18, add to the top is 19, but keep the bottom the same, so it's still over 3. So 4 1/2, we times by the bottom, which would be 8, and then add it to the top, which would be 9. So that equals 9 over 2. So we're going to do 19 over 3 times 9 over 2. So I've written the same thing, 6 1/3 times 4 1/2, but instead of 6 1/3 I've written 19 over 3, instead of 4 1/2 I've written 9 over 2. Okay, so one thing you can do at this step, which will help us write it in its simplest form, is you can divide anything at the top and anything at the bottom by a number to simplify it. So the 9 at the top and the 3 at the bottom, I can divide them both by 3. So that will leave 3 at the top there, and it will leave 1 at the bottom there. Now, this is really important because if I times these across, I would get a really big number. Now, I'm still going to get a big number, but it's a lot smaller and a lot easier to spot how to simplify at this stage. Okay, and some people call this the bow tie method because if I draw a nice bow tie over it, it can be any number at the top and any number at the bottom. So it can be down here, or diagonally across, hence the bow tie method. So now instead of doing 19 times 9, I'm doing 19 times 3, and you can do any method you want. I mean, some of you would do 20 times 3 and take away 3, but let's do a little grid. 19 times 3, 30, 3 times 9 is 27, so 30 plus 27 is going to be 57. And now we're doing 1 times 2, which is 2. Now, it says that it wants it as a mixed number, so we need to do that now. So 57 over 2, we need to make that mixed number. So we've got to work out how many 2's there are in 57. Well, I know that 56 divided by 2 is going to be 25 plus 3 is 28. So there's 28 whole ones and 1 remainder. So what you do is you work out how many 2's there are in 57, which is 28, and then any leftover, any remainders at the top, just create the fraction. So the answer is 28.5.
So this question is a simultaneous equations question, but it doesn't kind of look like the stereotypical simultaneous equation question because we're given a context for this. However, if you imagine S represents the price of the gumbo sweets and C represents the price of the raspberry chocolates, what we can do is we can write these two pieces of information as this. So 2 lots of the S plus 5 lots of the C equals, and I'm just going to leave it in pence rather than pounds. I find pence a lot easier to work with. And then we can write the second one as 4 lots of the sweets plus 3 lots of the chocolates equals 220. So to do simultaneous equations, you need one of the coefficients to be the same. Looking at the S and the C, to get the C's the same, I'd need to times the top, all the numbers at the top by 3 and all the numbers on the bottom by 5 to get them both to 15. But if I look at the S, that's 2 and that's 4, so all I need to do is times everything in this first one by 2, and it would get these S's the same. So I'm going to times 5C by 2, And I'm going to times the 180 by 2, which would be 360. So to get rid of the s here, so I'm just going to try and make this a bit clearer about where we're looking now. So we're looking, I might do it a little bit further up, we're looking at this part here. Now to make things a little bit clearer, when I subtract, which I'm going to do to get rid of the 4s's, we're going to have a bit of a problem because everything's going to be negative. So sometimes it's a good idea just to copy down the first equation again. So 4s plus, it's technically the second equation again. Oh, let me just rub that out. There we go. So 220. So I'm just copying it again so that when I subtract, which I will do, it can just make it a bit, well, make them positive, so make it a bit easier. Now at this stage we work downwards. So we're working downwards, we're looking at these two, and these two. And with simultaneous equations, you're always working downwards. Now we need to get rid of the 4s, and that's the whole point of doing this with simultaneous equations. And there's a little rule that if the coefficients are positive, so they're both the same, or both of them are negative, so they're both the same means subtract. So just remember that. Same coefficient, same sign, subtract. If the signs are different, so one's positive, one's negative, if they're different, the D in different is the D in add. So if they're different, you'd add them. But these are both the same, as we can see. So we're going to subtract them. So we're going to subtract all of these three. So 4s take away 4s is nothing, which is great. We wanted to get rid of those. 10c take away 3c is 7c. And 360 take away 220 is going to be 140. So I'm going to get my lines in now, so I can solve this. And to get rid of this times 7 here, we're going to divide both sides by 7. So we've got c equals, and 14 divided by 7 is 2, so 140 divided by 7 is going to be 20. So c, the raspberry chocolate, is going to be 20 pence or 0.20 pounds. Okay, but we need to work out what the price of the gumbo sweets are going to be. So what we do is we pick one of the original equations, and I'm trying to think what's going to be easiest. I like this one. So we're going to rewrite this, but instead of c, we're going to substitute in the 20. So it's going to be 2s, which we still don't know what s is, plus 5 times 20, which is 100, equals 180. Get my lines in. Okay, so first of all we're going to get rid of that 100, so we're going to take away 100 both sides. So 2s equals 80, and then that's a times 2 there, so we've got to divide by 2 both sides. So s equals 80 divided by 2, which is 40. And so once it in pounds, that's going to be 0.40 pounds. Now you can check this by putting both of these numbers into the second equation and check that it works. So 4 times s, which would be 4 times 4, £1.60, plus 3 times c, which is going to be 60p. Add the two together and you get £2.20.
Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the two together, it's 102. So there are 102 sweets altogether. The easiest way of approaching this question is to understand what multipliers are. Multipliers, you always start off with 100%. You work out what's happening, so let's say we're adding 40%, and then you work out the final percentage, which is 140%. The final thing you do is just convert it to a decimal, so divide by 100 to make it 1.4. That means you can multiply any number by 1.4 and it will go up by 40%. So in this question it says we have Billy, we have James, and we have Sam. And we're told that James collects 40% more sand than Billy. So he's got 40% more. We're told that Sam collects 20% more sand than James. So he's got 20% more. By what percentage has Sam got greater than Billy? Okay, now the obvious answer is 60. And if you write 60, unfortunately, you're not going to get the right answer. The way of doing this, as I said, is to understand multipliers. So, we imagine Billy starts off with 100%, and he's gone up by 40%. So that means he's now got, James has 140% of what Billy has. Now, as a multiplier, that's going to be 1.4. So whatever amount Billy has, we're going to times that by 1.4 to get James's amount. Then, James then has the 100%. We add 20% on to work out what Sam has, which is 120% of what James has. As a multiplier, that's going to be 1.2. So we're going to times James's amount by 1.2 to work out Sam's amount. Now the problem is we don't know what the amount is, but we do know what we're going to do to it. We're going to times 1.4, then times 1.2. So if we get our calculator, or if it's a non-calculator paper, then you have to do this the long way. And I type in 1.4 times 1.2. And that will tell me in total what I'm timesing Billy's by to get straight to Sam's. Like so. The answer to that is 1.68. Now that's as a decimal. If I convert that back into a percentage, that means Sam, if Billy has 100%, that means Sam has 168%. So therefore, Sam has 68% more than Billy. Now, if you're adamant the answer is 60, you need to go through this, because this is why this is such a high topic. It's understanding that actually it's not going to be. And the government, with all their statistics all the time, use this, and people think, oh, it's 60%. It's not. It's 68% for this question. Okay, so whenever we're asked to find an inequality or draw an inequality onto a graph, always draw the line but without the inequality in it. So instead of x is greater than or equal to 5, always draw the line x equals 5. If it can be equal to it, it's a solid line. If it can't be equal to it, it's a dashed line. Okay, so it's x equals 5, and I'm going to draw a solid line. So where does x equal 5? Well, x equals 5 here, and here, and here. And in fact, anywhere along that line, it's just a vertical line up. And that's the line x equals 5. and it's really important to remember which way around it is. Whenever you have x equals something, it's always a line from top to bottom. When you have y equals something, it's always a line from left to right. Okay, that's the line x equals 5, but it asks us to mark the region in the inequality with an R, so it's either going to be to the left or the right of this line. Well, it says that x can be anything that's greater than or equal to 5. So x could be 5, 6, 7, 8 on this graph, okay, because obviously it only goes up to 8. So anywhere this side of the line is absolutely fine, so I'm going to mark my R there. And actually sometimes the exams ask you to shade it in, so I just shade in that right hand side of the graph. Sometimes you shade in what you don't want, and if I was shading in what I didn't want, obviously it would be on the left hand side of that graph. So this question asks us to factorise, and this is a kind of special type of quadratic. Basically, one way of thinking about this is we've got an x squared plus 0x minus 121. So we need to find two numbers that multiply together to make minus 121 and add together to make nothing. Now the only way you can get two numbers that add together to make 0 is if they're exactly the same number but one's positive and one's negative. So we know that they're going to have to be the same number. So when I put in my two brackets, because it's a quadratic, and I put an x at the start of each, we know they're going to have to be the same number. Now 121 is not a number that's just been made up. It's always going to be a square number, otherwise this doesn't work. And one of them will need to be positive and one of them will need to be negative. Now if you expand that, you will find out that you've got 11x plus minus 11x, which cancels the x's out, which is why in the question there's no x terms. It's called difference of two squares, if you wanted to look it up to revise it. Okay, so there's a couple of formulas we need to remember with this. We need to know the trigonometric area formula, and that is the area is half a b sine c. A and b are the lengths either side of the angle, and c is the angle. And the other one we need to know is just normal triangle, half base times height. And it's a right angle triangle, so we've got the height and we've got the base there. Okay, so it says in the question that the areas are equal. So we're going to work out the area of A, we're going to work out the area of B, and then we're going to get them equal to each other. It's that simple. So to work out the area of A, we use our trigonometric area formula. So that's half AB. A is x and B is x, so that's going to be x squared, sine the angle, which is 30. And the other formula for the other triangle is going to be half times 1, well anything times 1 is just itself, times the height. Now whenever you've got an expression, always put it in brackets. So I'm going to put this in brackets. Okay, cool, right. We're going to tidy this up a little bit before we start solving it. I'll need longer lines than that, so I'll just draw these down a little bit longer. Okay, you need to know that sine 30 is a half, okay, and that's a requirement for the exam. So you need to know that that is just going to be a half without a calculator. We've got loads of videos on exact values that you need to know, and I think there's 8 of them you need to know. I probably got that wrong. But anyway, so we're going to expand the bracket. So half x plus, and our half of 3 is going to be 1.5. Am I sure? Yeah, that's right. Okay, cool. Okay, next thing we're going to do is, looking at that, I'm just going to times everything by 2. I'm just going to times everything by 2. And you've got to times everything by 2, so don't just do it once, both sides. You've got to times everything by 2, and actually that's part of the same term. So anything that's separated by plus or a minus, you've got to times by 2. Okay, so here we have x squared times a half equals x plus 3. Cool, right, okay, so next we're going to I'm going to times everything by 2 again, actually. Should times everything by 4. Get rid of the half. So we've got 2x plus 6. Okay, now looking at the requirement in the question, it says it wants it in the form a plus minus root b. Now that hints at the fact that we are going to complete the square to solve this. It means that basically we can't work out the exact answer, but we can show it as a square root. You could also use the quadratic formula. I'm not going to do that. I'm going to do completing the square. To complete the square, you need the x terms on the same side. So actually, I'm just going to write down what I'm doing. Get ahead of myself. I'm going to take away 2x from both sides. I'm going to extend my line even more. And so we've got x squared minus 2x equals 6. Now to do this, what we need to do is we need to put a set of brackets down, and it's going to be x, and it's going to be half of the number before the x. So if you have a look here, it's a 2 there, so we're going to subtract 1 inside the bracket, and we're going to square it. Okay, there's loads of videos on completing the square, so if you don't know how to do that, just check out the video. Just type in on maths completing the square. We've also got an erroneous 1 that generates, which we don't want, so we need to take away the 1 on the outside, equals 6. Next we're just going to add that 1 to both sides, really simple. So we've got x minus 1 squared equals 7. Extend my lines even more. We're nearly done though. We're going to square root both sides, so it's going to be x minus 1 equals root 7, and then we're just going to add 1 to both sides. So x equals 1 plus or minus root 7. Now the reason that plus minus is there is when you square root a number you get a positive and a negative answer. So our answer is a will be 1 and b will be 7. Okay, so Boxplot question. Now, it might be tempting to think that the information here is all you need to plot on the Boxplot. Well, it's not quite that simple. The 8 is the lowest, so I can plot 8. And the lower quartile is 16, so that's fine. I can plot that. And the median 19, I can plot that. But then I'm not given the other 2 that I need to plot. So to work those out, I'm given the interquartile range is 4. Well, the interquartile range is the distance between the lower quartile and the upper quartile. And if the lower quartile is 16, then the interquartile range will tell us that the upper quartile has to be 20, because we just add that on. So it's going to be here. So I'm going to do my box. Now the range is the biggest, take away the smallest. So if the smallest is 8, then to work out what the highest is going to be, then I just get the range, which is 14, and add on to the 8. So 14 plus 8 is 22. So the highest value is at 22. There we go, and that's our box plot. So that's question 1 done, or question A. Question B says, find how many students scored more than 20 marks. Well, 20 marks is our upper quartile. That means that 25% of the students scored more than 20 marks. So there are 140 students, so I just need to find out 25% of 140. And I can halve it, then halve it again, which is 35. So it's 35 students. Next one, question C. Estimate how many students scored less than 12 marks. So let's have a look at 12 marks. 12 marks is here. And 12 marks is halfway between the lowest value and the lower quartile. So we know there's 35 students who are in that quarter. And so we're going halfway there. Now we can't really say 17.5, that doesn't make much sense. So on this question I would expect that you could either write 17 students or 18 students. And what am I going to say? I'm going to say 17 students. it doesn't actually matter which one you write down, because you've shown that it's 17.5, well, you can't get half a student, so let's go for 17, or let's go for 18.
Okay, so this is an inverse proportion question. So the first bit I start with for this question is this line here. So as soon as I see that, I just write down B, and this fish symbol, which means is proportional to. The inverse is 1 over, so whenever it says inversely proportional or varies inversely, it's 1 over, and it says the square of A, so I'm just going to write A squared. Now I'm going to get my lines in. Okay, so to get that fish sign to an equal sign, I need to times the right hand side by K, so it becomes K over A squared. Now I'm going to pick a value of A and B. Now A and B are called variables, they're going to change. The K though is a constant. When we find K once, we found K for good. Now looking at these options, I kind of like this one the best. It's kind of simple. I like a nice simple fraction, 1/8 and 8. Okay, I can work with that. So it says B is 1/8, so I'm going to substitute in B is 1/8. And K we are trying to find out, and it says A squared, so it would be 8 squared, which would be 64. So I'm going to times both sides by 64, so I can find what K is. So it becomes 64 over 8 equals K, so therefore K is equal to 64 divided by 8, which is just 8. So putting that back into this equation here, or formula here, becomes this equation here. So B equals 8 over A squared. Okay, I'm going to use that to find out what A is when B is 2. So I'm going to write the same thing as I've written down for my answer here, but instead of B I'm just going to write 2. So 2 equals 8 over A squared. Get my lines down. Okay, so the first thing I'm going to do is times both sides by A squared. So the best thing to do is get rid of any brackets or fractions. And since that means divide, over means divide by A squared, I'm going to times by A squared, so it would be 2A squared equals 8. Then I'm going to divide by 2 both sides, so I get the A squared in its own, so it's A squared equals 8 divided by 2 is 4. Then I'm going to square root both sides. So this could be 2 or minus 2, but it does say positive value, so A equals 2. So if I put A as 2 into the answer to question A, it would be 8 over 2 squared, which is 4, so 8 over 4, which is 2, so B equals 2.
Okay, so in this question we're given 5 times square root 125, and we're asked to make it in the form 5 to the power of something. So this bit here is kind of our objective. We've got to make this so it's just a single power of 5. Well, 5 at the moment, well, that's quite nice of them to give us a 5, but 5 is to the power of 1, and that's going to be maybe important later on. So 5 to the power of 1 is just 5 times. Now, I notice 125 is actually 5 cubed, so I'm going to rewrite that as 5 cubed. 5 times 5 is 25, times 5 is 125, so that might help us. I'm thinking, right, that square root I can rewrite as to the power of a half. So I'm going to get that 5 to the power of 3, and I'm going to put that to the power of a half. To the power of a half and square root are the same thing, and that's something you need to know about indices. Okay, now the second rule that I'll need is if I've got a number inside and a number outside of a bracket, which I do here, I times them. So that's going to be the same as 5 to the power of 1.5, or 3 over 2. Okay, or 1.5. I could just write it as 1.5. It doesn't matter. Okay, it's sometimes easier to do just a top-heavy fraction, because obviously when you're writing powers, you're already writing small, and it gets a bit complicated otherwise. So it doesn't matter. And the other rule I'll need to know about indices is when you times them, you add the powers. So it's going to be 5 to the power of 2.5. And it says write your answer as a decimal. So it's 2.5 as a decimal is just 2.5. Now there are two things you always want to try and get rid of when you're rearranging equations or formulas. The first thing is fractions. So this fraction here we want to get rid of, and we do that by timesing both sides by y minus 5. So I'm going to write out the equation again just to make it a bit bigger. And we can imagine that there's brackets around the top and bottom of this, and that sometimes helps us to answer the question. I'm going to put my lines down. So the first thing I want to do is times both sides by that y minus 5. And you must do that. You can't access the numerator of the fraction otherwise. So this ends up with being x brackets y minus 5. And on the right hand side it's just the same numerator but without the denominator. Now I said there were two things you've got to get rid of. The first one's fractions, the second one is brackets. You've got to break them open. So we're going to times out these brackets. So we're going to have xy minus 5x. And the right hand side hasn't changed at all, it's just 10 minus 3y because we haven't done anything to both sides. So what I want to do is try and get all of the y terms to the left hand side and all of the other terms, so the x terms, the number terms, whatever, on the right hand side. So I'm going to add 5x to both sides, but I'm also going to take away, add 3y to both sides as well. So I'm doing 2 in 1 here. So it's xy plus 3y. And on the right hand side we've got that 10 that hasn't moved plus 5x. Okay, when we have this situation where we've got the brackets gone away and everything is, all the y's on the left hand side, and y is what we're looking to do it in terms of, what we want to do is factorize it, so we've just got a single y. So y on the outside, x plus 3. Now I know I said I wanted to get rid of the brackets, but we need the brackets here to be able to get y on its own. And the last step here is we just divide both sides by the x plus 3. So we get y on its own. So we get y equals 10 plus 5x over x plus 3. So let's put that into our answer box. Now it can be either way around here. It could be 5x plus 10, that's absolutely fine, still the right answer, over x plus 3. Okay, so this question seems really easy at first, but there's a bit of a gotcha in it. So the first thing I'm going to do is just calculate, click the wrong one. I'm just going to calculate the total length of this line here, because I think that will help me for later on. So that's going to be 35 centimetres, and the other one will be x plus 7, so that's not going to be helpful writing that down. Okay, so we've got two similar triangles, which means one's a direct enlargement of the other one. And so this seems quite a simple task relatively. So that 5 there grows to 35. Okay, and to do that we do, well, to work out the scale factor, so scale factor. So the 5 to the 35. The scale factor is going to be 35 divided by 5, which is 7. So scale factor is 7. So therefore this one here, to go to the larger length, which I can highlight, I'm just kind of, there's blue here. We're going to times that also by 7. So if this times is by 7, then this one will times by 7. So that will be 49. So x plus 7, the whole length would be 49. So to find x, it's just going to be 7 less than that. So it's just going to be 42. So x is definitely looking like it's 42. However, it does say there's two possible solutions. One of the flaws that we've made is that we've assumed that the 5 corresponds with the 35. That this length here corresponds with the total length here. However,
that's an assumption that we've made because it kind of looks like it does. And we're kind of used to questions where it does, because normally we know that these two here are parallel and therefore it definitely would. But there's nothing in the question that says these two are parallel. So it could be that this 7 centimeters here is the one that corresponds with the 35 centimeters here. So we've got to then run the figures again. So it could be that the 7 corresponds with the 35 centimeters. So the scale factor then would be 35 divided by 7, which is 5. So if the scale factor is 5, then we're going to look at this top one here, the 5 centimeters here, and times that by 5 to get to the x plus 7. So it'd be x plus 7 equals 5 times 5, which is 25. And then take away the 7 both sides, which would be 18. It's very, very difficult to get your head around that, because it's so convincing that these two lines are parallel, but they're definitely not. And the hint in the question, in this one anyway, is that it's saying that the diagram is not drawn accurately. And in the exam, if they ask a question like this, you'll notice that the two lines here are going to be subtly different sort of slants on them, so that it's not too misleading. But yeah, very, very difficult to spot, and sometimes in the exam you'll have questions like that. You just need to try and think through what assumptions have you made, and are you right to make those assumptions.
To simplify a fraction, you need to divide top and bottom by something. So if I just try and divide top and bottom by something now, I need to find something that all 6 terms have in common. Well, there is nothing that all those terms have in common. So the way of starting this is to factorise the top and bottom, so put them into brackets, and then something will turn up. So let's factorise the top. So I know it's going to be x at the start. I need 2 numbers that add together to make 12 times together to make 35. Well, that's going to be 7 and 5. Then I need to factorise the bottom. Now, a little bit of a cheat here. I know one of them will be the same. So either one of them is going to be x plus 7 or one of them is going to be x plus 5. So I need 2 numbers to add together to make the 10x times together to make 21. Well, I know that 5 doesn't go into 21, but I know 7 does. So x plus 7 and x plus, well, to make the 21 and the 10 needs to be 3. And all you need to do is divide top and bottom by, let's do it top and bottom. Get rid of that. Ugh. So all I need to do is divide top and bottom by x plus 5, x plus 7 even. And what that does is just gets rid of that and gets rid of that. The fraction stayed the same, but now it's x plus 5 over x plus 3.
Okay, so a circle theorem question. With these questions, it's really important that you set all your working out and you give reasons for every step. So I'm going to do it one way, and there probably are slightly different ways of doing it. And as long as you give the reason, then that's absolutely fine. We're asked to find ODF, and just to help us, I'm just going to mark that on. So it's that angle there. Now, just finding this angle here, which we're going to start off with, it doesn't mean that it's the same angle as that. You can't guarantee that the arrow is going to be symmetrical. So we're going to start off with this one. But how do I show the examiner that's the one I'm starting off with? Well, the letters are there so you can actually write down what you're trying to find. So I'm looking for angle OBC, and you can write the word angle or angle OBC, or you can just do a little angle on top of the B. And we know that that's going to be 90 take away 51, and the reason is that angle between tangent and radius is 90 degrees, and that's one of the circle theorems. So AC is a tangent, and OB, because O is the centre, is a radius. So the whole thing's going to be 90. So when I do that, so I'm going to do 90 take away 51, which is 39 degrees. So we know that that's 39 degrees. And it's absolutely okay to mark it on the diagram as well. And actually sometimes, not often, but sometimes the examiner will look at the diagram and might give you some extra marks because you didn't show the working out. But most of the marks for these types of questions are for the reasons, and you can't really show reasons on the diagram in a way that the examiner is going to be able to see it. So I also know, let's have a look what else I can work out. Well, that's also 90 degrees and that's also 90 degrees. And ADOB is a quadrilateral. So we can work out which angle we're going to pick next. Well, let's pick this angle here next. So what's that? DOB. So angle DOB is going to equal 360 take away 30 plus 90 plus 90. Okay, so need to give a reason. Well, let's work it out first, and we can give a reason afterwards. So we're going to take away, what is it, 180 plus 30, so that's 210 from 360. That's going to be 150 degrees. And the reason is angles in quadrilateral. And we should really say that the angle ABO and ADO are angles between a tangent and radius as well, but I'm not going to. We've already used that reason, and it's clear in our diagram that we've just repeated the same reason. Okay, so angle DOB we've got as 150. So let's mark that on our diagram. So we can work out this angle here. Okay. And it's very difficult to know what to call this angle because we've already called DOB once. So we could call this other DOB. Let's go for that. Other DOB equals 360 minus 150. Okay, and the reason for that is just angles on a point. So that's 210 degrees, angles on a point. Okay, so what are we up to next? Well, we can work out this angle here, and actually let's mark on the 210 as well. So we've got it all on our diagram. We can work out angle DFB. So DFB, and this time we're using the circle theorem that says angle at the centre, which is the 150. Is twice the angle at the circumference. So angle at the centre is twice the angle at the circumference, so it's going to be 150 divided by 2, which is 75 degrees. So angle at centre twice angle at circumference. Now, if your teacher's given you different ways of writing the circle theorems down, that's absolutely fine. There is no strict way of writing it down. So that's going to be 75 degrees. And if you look, we've got the arrowhead BFDO, which is a quadrilateral, and we've got 3 of the lengths. So we can work out ODF. I'm going to have to scroll up because my memory is not that good. So we're going to take them all away from 360. And what is it? 210, 75 and 39. Okay, so we're just going to take those away from 360. And obviously if you're doing this in the calculator paper, then please feel free to use a calculator. And we get 36 degrees, and again it's just angles in quadrilateral. As a rule of thumb, my experience with these questions is they're normally looking for between 2 and 3 reasons. Obviously on this question there's an awful lot of reasons, but if you walk out of the exam and you just think, oh hang on, I only wrote down 3 and actually there's a 4th, sometimes you'll get the full marks, so don't panic too much. Just when you're doing the question, try and write down as many reasons as you can. Even really obvious ones like angles on a straight line or angles in a quadrilateral will help you get the marks. Normally, again, for circle theorem ones, they're looking for circle theorems as well as those ones. Okay, the first question asks us to find where the y-intercept. Now, at the y-intercept, x is 0. So if you have a look at our equation, these two will be wiped out because anything times 0 is 0, and we're just left with y equals -4. So x is going to be 0 and y is going to be -4, so that's nice and easy. And basically, whenever you just have a number in an equation, the y-intercept is that number, so it's going to be -4. The next question is pretty complicated, so we're going to break this down. It does ask us to complete the square. It gives us a bit of a hint. So I'm going to start with completing the square. So we've got x squared minus 8x minus 4. And to complete the square, what we do is we put brackets and we do x, and we do half of the coefficient of b. So half of this, and b is always the number before the x. So half of -8 is going to be -4. And we close bracket and put a squared there. Now if I expand that up here, x times x is x squared. Then you have -4x, -4x, and plus 16. So we get x squared minus 8x plus 16. Now, we want the x squared minus 8x because that's what the equation in the question is, but we don't want this bit, that plus 16. So we're going to subtract, get rid of the 16 by taking away 16 there. And we've also got the -4, which is in the question to have as well. And we do have videos on completing the square, which go into it a little bit more detail than I'm going through here, so watch those if you're not sure. Go put the -16 and the take away 4 together. Okay, so here we've got an x and we're subtracting 4, we're going to square that and then take away 20. Now, the next thing to think about is comparing it to y equals x squared. Okay, y equals x squared looks something like this, and I'm going to do a really bad job of doing this, but something like this, okay? And that's y equals x squared. So if you think about that function, and we're going to call that f of x, then what's happened between that and the one that we've just created? Well, in terms of f of x, this one is going to be f, which is the function is squaring, of x minus 4, okay, and we're going to square it, take away 20. So think about functions. What do the bits do? Well, anything in here moves it in the opposite direction on the x-axis. So -4 would move it 4 to the right, and anything in here will shift it on the y-axis, and actually it will be in the correct direction. So anything inside the bracket affects the x in kind of the opposite direction, and anything outside the function will just affect the y. So the minimum point on y equals x squared is 0, 0. And we're moving to the right 4, and then we're moving down 20. So it'd be -20. So the new point will be at 4 minus 20, and that's going to be the point at t. A little bit complicated, but once you get really good at completing the square and really good at understanding transformation of functions, then this question just brings the two together and you shouldn't have a problem. If you had any issue with this, obviously have a look at completing the square and have a look at transforming graphs and transformation of functions.
and that will help you massively with this. This question might just ask you to rationalise the denominator. It might ask this question in the form that it's in, or it might ask you to show that that fraction is the same as another one, where you'll get marks for the working out. So to do this one, what rationalising means is basically what this one's here, because if you look, there's no root at the bottom there. What rationalising means is to get rid of the square root off the bottom of the fraction. Now I'm going to write this out again to make it a bit bigger. Now the only way we can do that with this question is if we times top and bottom by kind of the opposite of what it shows at the bottom. So instead of 11 plus root 5, I'm going to times it by 11 minus root 5. But if I do that to the bottom, to keep the fraction the same, I must do it to the top. So that creates a kind of quadratic surd. Okay, you do it the same way as you do quadratics, whichever method you want, first outside, inside, last, or double smiles and rainbows, or smiley face, or whatever you choose to do it. So I'm going to do the top first. So I'm going to do 5 times 11, which is 55. I'm going to do 5 times minus root 5, which is minus 5 root 5. I'm going to do 11 times root 5, which is 11 root 5. I'm just going to extend my line a little bit. And root 5 times minus root 5, well, positive times a negative is a negative. And any surd, when you times it by itself, it just becomes that number. So root 5 times root 5 is just 5. Okay, let's do the same with the bottom. So 11 times 11 is 121. We've got root 5 times 11, which is plus, it's 11 root 5. Then we've got minus root 5 times 11, which is minus 11 root 5. And then we've got positive root 5 times negative root 5, which is minus 5. Okay, now you might see what happens at the bottom. The whole purpose for doing this is you end up with the surds cancelling each other out. So let's simplify the top. 55 take away 5 is 50. And minus 5 root 5 plus 11 root 5 is going to be, well, if you think about it, you've got 11 of something and you're taking away 5 of it. Well, what you're left with? Well, you're left with 6 of it. So it's plus 6 root 5. Okay, now let's go through the bottom. Well, the two middle ones have cancelled each other out, so it's 121 take away 5, which is going to be 116. Okay, can I do anything else with this? Well, I don't think there's something that's in 56 and 116 apart from 2, so we can cancel all of that. We can halve all of those, so that becomes 25, that becomes 3, and that becomes 58. Now, the 3 doesn't go into 25, so we can't cancel it any further. So it's going to be 25 for A. B is the coefficient of the root, so it's going to be 3, and the bottom number is 58.
Okay, so there's a lot going on with this question, and there's a lot of areas of maths that this question is involving, so we need to be quite good kind of across the board with our knowledge of the different areas of maths. The first thing to notice is we've got the equation of a circle. Now, important thing to highlight with this, and we'll do a little diagram up here. Because it's y squared plus x squared equals a number, we know the centre of the circle is going to be at 0, 0. So the circle looks something like this. I am not good at drawing circles, actually that's not too bad. And that can help us, or that will help us later on. So we know that, first of all, well, having a look at this question, so we've got a point T, which I'm going to put here, so point T, and it's on the circle. Now, we're looking for the equation of the tangent, so if I draw the tangent on, probably not going to be as good as my circle, but we're looking for this equation here.
But something that will help us is to understand that a tangent and a radius hit each other at 90 degrees. So if I draw on the radius, which we know starts at the centre, we know that that bit there is going to be 90 degrees. So first thing we're going to do is work out the gradient of, we're going to call this M1, the gradient of this radius. Then we're going to find out, because we know that, we're going to find out what the gradient of this second line is, and then we're going to find out what C is, so we can actually find out the equation of the line, because it will be y equals mx plus c. The only thing we've got left is c to work out if we've already got the gradient. So a lot going on there. We're also told the coordinates of t, but they're kind of in a not very helpful form. They've got surds and they're in fractions, so it's not the most helpful piece of information that we can have. So I'm going to work out M1 first, which is the gradient of our radius. So I'd probably show the examiner that I'm working out the gradient of the radius. So to find out the gradient, we do change in y over change in x. Now over just means divide. Now because we know that 0, 0 is on the radius, all we can do is do the y coordinates given to us here, take away 0, and then put that over the x coordinate, take away 0. So it's just going to be 5 root 17 over 3. Over means divide, so I'm going to show it as a divide sign, and then 10 over 3. So another area of maths we need to know is KFC, or same change flip, that whenever we're dividing with fractions, we keep the first one the same, we change the divide to a times, we flip the second one. Now we can times them, so 3 times 5 is 15, so it'd be 15 root 17 over 3 times 10, which is 30. And if you look at the 15 and 30 cancel to make that just 2, so root 17 over 2. So M1 is root 17 over 2. Cool, right. Now we're going to work out the tangent. I'm going to do this one in black because green's not the nicest thing to write in. So I'm going to start working out M2, which is our gradient that we actually want. And to do this, we know that the M1 and M2 are going to be perpendicular because they touch each other at 90 degrees because of circle theorems. The angle between a tangent and radius is 90 degrees. Therefore, we know that they'll multiply together to make -1. So basically, to get from one to the other, you find the reciprocal and you change the sign. So we've got root 17 over 2, so that's a positive number, so it's going to be negative. And we're going to flip that, so it becomes 2 over root 17. Cool, we've got our gradient. So we're going to do y equals mx plus c. Now we know a y coordinate, which would be 5 root 17 over 3, because that's both on the radius and the tangent. So we know what the m is, which would be -2 over root 17, and that's going to be times by the x. So I put the x up there, plus c. So I'm going to put my lines in. I'm going to give myself a little bit more room here, because I think it's quite easy to get congested. So let me have my straight lines down. Okay, so first thing I'm going to do is add the entirety of -2x over root 17 both sides. So it would become 5 root 17 over 3. I'm just going to add that 2x over root 17. Now, let's get rid of that. Equals c. Now I left that x in just so that we could give ourselves a bit of room, so I could show you a little bit easier what's happening. But I'm going to substitute that x in, and so that x is 10 over 3. So it'd be 5 root 17 over 3 plus 2 over root 17 times, and let me just get that x coordinate, 10 over 3 equals c. So I'm just going to sort that bit out. So 2 times 10 is 20, and then be just 3 root 17. Okay, let's extend these lines a little bit. Okay, so now we've got a problem here because we're adding two fractions but they don't have the same denominator. But if I times both the top and bottom of the left hand fraction by root 17, they will have the same denominator. So I'm going to do that now. So I'm going to do 5 root 17 times root 17. Now when you do a root by itself, when you times a root by itself or a surd by itself, it just gets rid of the square root. So we end up with 5 times 17 at the top, which would be 85. And at the bottom we'll just have 3 root 17 plus 20 over 3 root 17. So all I've done there is times the left-hand fraction, top and bottom, by root 17, which is odd because you normally go the other way with it, but well, I suppose I could have rationalised the right-hand side. Doesn't matter too much for this question. Okay, so now I can add the tops. So it would be 105 over 3 root 17 is equal to c. Now 105, if you add up the digits, 1 plus 0 plus 5, it equals 6. And if that number, when you add up the digits, is divisible by 3, then the whole number is divisible by 3. My knowledge of my 35 times table is good enough to know that I know that 105 divided by 3 is 35. So that would be 35 there, and that would just be root 17. So c is 35 over root 17. Took us a while, but we got there. Okay, so looking back at my y equals mx plus c, we know what m is now. So we've got y equals, and it's minus 2 over root 17 x, and we're doing plus 35 over root 17. Now if you look at the question, it says it wants it in a slightly different way. It wants the root next to the y, it wants a number, and then minus whatever the x bit is. So we're not quite finished yet, but we're just needing to tidy this up a little bit. And what this is suggesting that we do is times everything by root 17. So we times everything by root 17. Don't forget that you've got to times each term, so that's all 3 terms. So here we've got y root 17 equals minus 2x, because it's got rid of that over root 17, plus 35. And it wanted it swapped around, so we'll just tidy that up. So it's 35 minus 2x. So looking back at the question, a will be what's in the root, which will be 17. C will be the number on its own, so C, which is 35. And the b will be the coefficient of the x. Now, but technically, because it's got a minus in there, b is 2. But in the exam, I can imagine that if you wrote minus 2, it depends really. I mean, technically b should be positive 2 because it has a minus in this bit here, but if you've got this far, I think that would be harsh to them taking away marks for that.
There are a few different methods to answer this question, but I prefer the method where we just replace f of x with y because it becomes a lot easier. So I'm just going to write out the same equation. Now, when you want to find the inverse, which this is, of the function, all you do is swap the y and the x around. So we're going to have x equals 4y minus 10 over 7. And then all we need to do is get it, so we've got y equals. So the first thing I'm going to do is times both sides by 7 to get rid of the fraction. So we've got 7x equals 4y minus 10. Then I'm going to add 10 both sides. So we've got 7x plus 10 equals 4y, and then I'm going to divide both sides by 4. So I've got 7x plus 10 all of that over 4 equals y. Now, it's not y really, it's f inverse of a function. X equals 7x plus 10 over 4. And the 7x and the plus 10 can be either way around. So 7x plus 10 over 4. I hope you enjoyed that video. If you did, please click like, and if you really enjoyed it, please click subscribe. Also, make sure to check out our website. Our website has a lot more on it, and you can just revise anything you want. Finally, very, very good luck for those of you doing the resits in November, and I hope you get the result you want. Thank you very much.